Thank you.
Good evening, ladies and gentlemen. I hope that you had a great BE Sites. This is the last talk. Let's get this through this. My name is Kartik Adak, and I recently completed my master's from University of Warwick. This is who am I. I have 3 years of experience in cybersecurity, specializing in threat intelligence, incident response, and pen testing. And these are few of my achievements and certifications that I achieved throughout my years. Now let's get straight into the topic. So first thing that comes to my mind, and I am sure that it comes to your mind as well, why did I choose my project? Why did I choose OWASP threat intelligence? So the first problem statement that I saw was 90% of the global attacks are through web application. And the attack vectors that you see are becoming more advanced, but the mechanism of defense are not matching up. So the gap between the attack vector and the solution is too high. So I wanted to just lower down the gap. That's why I made project objectives. And these are the 3 project objectives that I created. First, I thought of deploying honeypots, which would just collect attack data, and that would store in a S3 bucket. That would be my central repository. And I would use mod security and OWASP core rule set to just have a tagging of what kind of attack vector is that. It could be SQL injection, it could be brute forcing, and different attack vectors. So the tagging comes through OWASP core rule set, and then the entire data is getting converted into JSON format, because the tool that we are using is JSON visualizer. So in generally, like, it stores in mlogc because it's mod security logs. So we have to convert it into JSON format. Moving on to the next slide. This is the entire architecture of my project. So if I run through how the attacker and the life cycle of this attack architecture would work, is that if you see the browsers, they are the browser that the attacker is going to use and going to interact with our honeypots, that is Amazon EC2 instance. If you see in Amazon EC2 instance, there are multiple instances which are spread across different geography, and it has mod security core rule set inside the EC2 instance. So if the attacker is attacking a EC2 instance, it is getting the tagged according to mod security core rule set, and then the attack vector is being noted down in logs and then sent it to S3 bucket, which is used as a central threat intelligence database. This you can alone use it to share with different teams, and you can create your own threat intelligence by creating your own rules. But in this case, I have used a visualization tool just as JSON crack, where you can visualize, which we'll be seeing in the future slides. Moving on to the next one. This is the entire description of my architecture. So the first thing that I am going to do, or I have done, is distributed geographically AWS EC2 instances over London, Oregon, and Stockholm. And then I configured different mod security rules, that is SQL injection, XSS, brute force. We can also call it as honey traps. And I have converted the logs into JSON format because our JSON visualizer does not follow mlogc. And then we have stored that into S3 bucket for our centralized storage. And then we use JSON crack for visualization of attack patterns and trends. After we get the visualization of the attack vectors, now we know that there are certain payloads that are bypassing the parameter. So if that's so, we have to refine our entire honey trap. So that is the last thing that we are going to do, that is refining our rules. moving on to the next slide. As I said, we are creating honey traps. Honey traps are nothing but use cases which are used to tag those attack vectors. For example, if a particular advisory is trying to attack brute force, so how will we understand that it's a brute force attack? Through our use cases. So use cases are nothing but the attack vectors that has certain keywords which are just tagged when you pass or attack through certain browsers. And we will see one of the attack vector, that is SQL injection. We'll see the demonstration. We'll also see the rules, how I created the honey trap. This is my mod security configuration file where you can see that there are few honey traps. Don't worry, like I will maximize the image and we'll see one of the honey trap, that is SQL injection. So this is my honey trap. This is used to detect SQL injection. So here, if I break down the entire honey trap, the rule says that if there is any argument or argument name, request header or request URI, that means anything on the URL that says that there is a keyword called select, union, update, delete, drop, alter, or execute, then please send a message that SQL injection honey trap is triggered. Now, how does that work? Let's see in the demonstration. So in this case, you can use some automated attacks such as SQL map, but I prefer using Burp Suite. So if you can see, it's a post request for a login page. So in the login page, there were two, as you can see, there are two parameters, username and password. So I have tried to tamper the username by putting the payload of union select null null null. And now let's see if our log rules can just detect this. I don't know if this image is clear, but you can see that there is a username parameter that is shown, which highlights that this payload is getting detected. And there is a warning message of SQL injection is getting detected. This is nothing but a visualization tool that I talked about, JSON crack. Moving on, the key findings for this project was that I found that 91% of the detection rate was success in SQL injection, and XSS and brute force were effectively flagged, and it was the most common pattern in the attack vector. And the trend insight that I got from this project was that London recorded the highest activity, and there was frequent exploitation of admin directories and robot.txt. And the limitation that I saw in this project was there was approximately 10% of false positives. That means a lot of attack vectors were getting undetected. So what I used to do is just refine the rules again and again, as it follows the agile process. You have to do again and again. And challenges with this project was that I faced a lot of outdated components. That was an issue. Maybe if I use some other tools, maybe it would work better. So these are the future enhancement and recommendation by me. We can have more honeypots so that we get more geographical location attack vector, because every geography has its own way of attacking. Maybe somewhere SQL is prevalent, but some other places they prefer more brute forcing. It could be anything. We have to improve automation for faster mitigation, because there is a lot of dependency of logs getting parsed into our database, and then we are putting the database data into a JSON crack tool. So to fasten the process, we have to automate a lot of process. Although I have created an automated script that uploads it to a S3 data bucket, but yeah, I did not have any solution to upload it to JSON crack. I had to do it manually. So that's why there needs to be an improvement in automation. And for brute forcing, like it was able to efficiently flag common attack patterns. The recommendation that I would give is there should be regular update of honeypot configurations. Second thing, like as we created a threat intelligence data set, we can collaborate with different organizations and different people to showcase our threat intelligence data set. And there could be continuous monitoring to adapt emerging threats. If you have any questions, please do let me know. Thank you. First of all, I want to thank Nikki. She helped me a lot with this presentation and she guided me a lot. Secondly, I also want to thank B-Sides for giving me such a wonderful opportunity. And finally, you guys who have been a lovely audience. Thank you. And I am actively looking for job roles. If anybody has any job, you can contact me through my contact details. Thank you.
We have a question, right? Okay.
So one quick question, with mod security, are you blocking or are you just recording?
So it's the rules that we create, the honey trap is actually alerting, but you can keep blocking as well. It's on you how you want to maintain it. If you just want to create a threat intelligence data set where you want to see what are the more attack patterns, you can just put it on logging, but you can block it as well.
Okay, and can you install it on any web application?
Yes, you can put it on any web application.
Thank you.
Yeah.
Any more questions? Oh.
Hi, Kartik. Great presentation.
Thank you.
I think the focus or the emphasis of this honey trap and this third is more on SQL injection and cross-site scripting and brute force attack. Those are the primary use cases. Can this be extended to other security use cases, especially around OWASP top 10 threats?
Yes, you can. It depends on the web application as well. My web application that I created was more focused on login pages. That's why these were the more prevalent attacks. But if you have more complex functionalities, if you want to apply more APIs or there is more user interaction, search bar or something, so there could be more injections and different OWASP top 10 vulnerabilities. Like maybe I can show you CSRF if there is some sensitive data. You can add, there's no problem with that.
We've got another question at the front.
Did you think of any of the other services like SSH or SMB or any other protocols?
Yeah, so this was purely on the basis of web application. So it was more focused on 80, 8080 and 443. But for SSH, I don't think so. Mod security does logging of SSH because it is strictly of web application. So maybe we can create our own rule, custom rule, but this is out of scope for this project.
Any more questions? In that case, thank you very much, Kartik.
Thank you.